The testes in the males produce sperms and ovaries in the females produce ovum. Gametogenesis is further classified into 1. Spermatogenesis, 2. Oogenesis. Spermatogenesis begins at puberty. Significant increase in the secretion of gonadotropin releasing hormone which stimulates the pituitary glands and stimulates the secretion of two gonadotropins, luteinizing hormone LH and follicle stimulating hormone FSH. LH acts on the Leydig cells and stimulates synthesis and secretion of androgen. Androgen in turn stimulates process of spermatogenesis. FSH acts on the Sertoli cells and stimulates process of spermatogenesis. Immature male germ cells, spermatogonia, produce sperms by spermatogenesis. Each spermatogonium is diploid, which divide by repeated mitotic division containing 46 chromosomes. Spermatogoniums present on the inner side of seminiferous tubule multiply by mitotic division forming primary spermatocyte. Primary spermatocyte undergo meiotic or reduction division forming secondary spermatocyte. Secondary spermatocyte undergo second meiotic division to produce 4 equal haploid spermatids. 4 equal haploid spermatids transform into spermatozoa, sperms, by a process called spermiogenesis. Sperms moved from seminiferous tubules by process of spermiation. The seminal plasma along with the sperms constitute the semen. The functional sex accessory ducts and glands are by testicular hormones, androgens. Structure of a sperm. It is a microscopic structure composed of a head, sperm head contains an elongated haploid nucleus, the anterior portion of which is covered by a cap-like structure called acrosome. The acrosome is filled with enzymes that help fertilization of ovum. The middle piece possesses numerous mitochondria which produce energy for the movement of tail that facilitates sperm motility essential for fertilization. The human male ejaculates 200 to 300 million sperms during coitus. 60% must have normal shape and 40% show vigorous motility. Oogenesis. The process of oogenesis involves development of an ovum which starts from a primordial oocyte around which 2 to 3 layers of cells from the ovarian stroma. The outer layer is fibrous and known as theca externa. An inner layer which is somewhat vascular and cellular is theca interna. The cellular mass is soon separated into 2 parts by the collection of fluid, the liquor folliculi near its center. A homologous membrane, the zona pellucida, appears between the primary oocyte and the follicular cells. These cells increase rapidly, forming many layers. The theca layer are differentiated and the follicle assumes a deeper position in substance of the ovary. The primary oocyte divides meiotically, giving off the first polar body and becomes a secondary oocyte. The germ cells become mature ovum after the second polar body is released. During later stages, the fluid-filled spaces, the atrium appears in the membrane granulosa layer formed from the cells separated off by the liquor folliculi. The resulting structure becomes a vascular or graphene follicle. As the follicle matures or ripens, it projects out from the ovarian surface as a small cyst-like oval swelling which bursts to liberate the ovum, the process being called ovulation.